I think it will not take too much time, not 30 minutes, I guess 10 or 15 minutes. Agenda, what we are going to cover, and expectations, we already know. So first of all, what we are going to do if our amazing service will reach like 100,000 active users and we will get a lot of requests. Yeah, a lot of requests. How to deal with it and what approaches and technologies will help us to handle all these requests. So first of all, we should care about our capacity management. Yesterday, we talked about monitoring things, logging, tracing, and so on. So we should carefully monitor our current performance, CPU, memory, bandwidth, and so on. And also, we should careful planning our for sudden spikes and be prepared to horizontal or vertical scaling. I'm sure you already know about horizontal and vertical scaling. We covered it in previous sessions. Also, but what was in the beginning? In the beginning was the monolith, but right now many companies using monoliths also if you're not too big and you don't have enough money to manage microservices and you don't have too much clients, monolith is a great solution because it is really easy to manage, easy to develop and deploy. So monolith is a single self-contained code base for your app, all business logic in the same code, and usually you have one database to store all your data. But when huge traffic comes, you should think about how to split all your logic to different microservices and we start dealing with front ends, back ends, different front ends, different back ends, and load balancers. After, you have a question? After monolith, when we have monolith, even front-end application could be delivered from the single server, like even from the single application server. But in microservice, yeah, let me.
Actually, maybe just share the window instead of the screen. Because sometimes the projector freaks out. Yeah. Much better.
Nice. Okay. In microservice architecture, frontends usually delivers from other, like from separate services. So you have like Nginx containers or something like that, and you can, when user try to access your server, first of all, it could be routed to, for example, service A, then it receives front-end application, and after this front-end application start to making requests that will go to, for example, load balancer and split between your backends. Yeah, and Kubernetes will help us with all these things, with load balancing, managing your backend stuff, and so on. You already know how to scale your pods, what is deployments, and so on. And right now we are going to like recap a little bit all these things. So why we should use Kubernetes? Kubernetes is really cool. So it helps us to handle high traffic with automated resource allocation. It's reliable, it has great flexibility, efficiency, helps us to make cost optimizations, also team productivities, increases and it is open source. So the core elements, like core entities of Kubernetes, is the cluster, which has nodes, and on each node we have pods. Inside pods we have different containers. So also Kubernetes has autoscaling features. We saw in today's demonstrations how it works. So if your traffic goes up suddenly, Kubernetes can handle it and up more service instances to handle all this traffic. So also it has a self-healing feature. If something goes wrong with one of your services, this service will be replaced with the health one as much as possible. But how are we going to automate after scaling, for example? We have two approaches. It is HPA, horizontal pod after scaling feature, that helps us to define configuration and increase number of service replicas. If, for example, your average CPU utilizations comes to 17%, for example. It is the simple HPA architecture. So we have HPA deployments and HPA tracks your, for example, metrics, CPU utilizations, and increase the number of pods. Also, another useful thing, it's KEDA, Kubernetes Event-Driven Autoscaling. It is more powerful, and it has a lot of scalars you can connect to it. You can see the number of it here. So, for example, if we have Prometheus Prometheus scalar, we can define and tie on your Prometheus metrics, write the query, and we can say that if the number of I don't know, requests more than 100 per second on each pod, you should scale your application and up, for example, 10 pods, not 5, 10 pods. And you can connect it to message queues, to Prometheus metrics, even to logs, I guess, and to database, and write queries to track performance and increase number of replicas. Here is an example template for Kubernetes event-driven autoscaling.
Can I ask you a question?
Yeah.
Is the services in the picture supporting triggers?
Yeah, it's like triggers. So let me show the KD architecture. So here is KDA, and we have trigger source as like these scalars. We check any events from it, analyze these events, and then delegates all work to HPA. So KDA works with HPA, and it decide, and after it, when trigger like processed, HPA can scale your Kubernetes application. So another great approach to deal with high load is using cache. For example, it could be two types of caching. It's client-side cache and server-side cache. For client-side, it can be just mobile applications, a browser where you can save all the data and not to get all this data from the server. On the server side, we can use Redis, Memcached, or any in-memory solutions. If in-memory solutions could be used in really special cases, if you need to respond really fast, you can cache all data in memory, even if you have different pods. So if it is possible to have all this data in pods, you can use in-memory solutions. Message queues. Yeah, message queues also allow us to build systems that can handle high load. It helps to build event-driven architectures, and it handles spikes in traffic without overloading the system, because we don't need to respond to requester as soon as possible, but it is better to process messages as soon as possible, but you can do it in more like flexible way. So just you have a lot of consumers, they getting messages and process them in more chill way and so on. Also with message queues, you can scale your application very well. Because yeah, you can scale your application very well, because if you have I don't know, just request response model, it is you need to handle, like, okay, let's go next slide. So there are two popular solutions for message queues. It is Kafka and RabbitMQ. Also, it is ActiveMQ, but I didn't have experience with them, with ActiveMQ. So Kafka is for really big, huge traffic. RabbitMQ is more for complex logic. If you need like complex logic in message queues, like you need to route your messages like from one queues to another queues. You need to keep so if you have complex message queues logic, you need to use RabbitMQ. If you need to has high through output, you need to use Kafka. It is really fast and very great for microservices. Then also you can use distributed database. It also helps to scale your data storage horizontally and provide high availability and fault tolerance. This is an example of most common distributed databases: MongoDB, CockroachDB, CassandraDB. But you should use them really carefully and when you really need it. So if you have, I don't know, 100 requests, even 1,000 requests per second, I don't think that you need to use them. You should have really high load to use these solutions. So that's it. If you have any questions, let's go. So great, we can finish, and it was the last session. Yeah, question. Yeah.
Is it easy to scale out the nodes of Kafka or Redis?
Is it easy to scale?
Yeah, scale out.
Just horizontally scaling
Yeah.
with Kafka? Yeah, sure. You can easily scale your application horizontally using Kafka, because Kafka was made for distributed systems. Yeah, and the entire architecture allows Yes. With RabbitMQ, the same. Three, two, one, done.